Welcome to Lecture 12, 1.6, More Equations and Applications. Alright, so these problems are often very nice problems, so I would make sure to know how to do these. These are sort of the mini off-twists of quadratics and solving equations. So they require slightly different methods. First thing to note, though, for this problem is it is an equation. Okay, always keep that in mind if you're working with an equation or an expression, because the things you can do with equations you may not be able to do with expressions. How do I know it's an equation? Because I'm given an equal sign in the beginning. Alright, this has 4 terms and I'm asked to solve. And it all has the same variable. So I'm going to treat this like the zero factor property and see if I can factor this. Now there's 4 terms. How do I know, or what ways do I have for factoring a 4-term polynomial? Well, I have grouping. So let's go ahead and do that with grouping. Okay, so I'm going to put in my grouping symbols. But remember, when I do this to this side and I have that minus sign there, I need to be very careful. This has to change sign. If it was a minus, it becomes a plus. If it was a plus, it becomes a minus. Now we're going to go ahead and focus on factoring each of these individually. Do they contain like terms? Well, the first group, they both share a 4x squared. Then we're left with an x plus 3. Minus, now let's factor this group. They both share a 9. So taking that out, we're left with x plus 3. Now let's look at this whole problem. Do these terms share a factor in common? Yeah, they do. They both share the x plus 3. So we can go ahead and factor that out from both terms. And what's left from both of these? Well, in the first one, when I take out the x plus 3, I'm just left with the 4x squared. Then on the second one, when I take out the x plus 3, I'm just left with a minus 9. So that equals 0. Alright, now once again, let's just pause and check. Can I factor either of these? This one looks suspicious. It's a minus, and there's a 9 and a 4x squared. That looks like the difference of squares. So we can factor this one into, let me bring down the x plus 3, factoring this into 2x plus 3 and 2x minus 3, because we have the difference of squares right there. Okay, special factoring methods, remember those. Alright, this is a nice problem. Okay, they're all factored, so now, using the zero factor property, let's set each factor equal to 0 and solve. Okay, so solving, I get 2x equals negative 3, x equals negative 3, 2x equals positive 3. This one's already solved for. X equals negative 3 over 2. And x equals 3 over 2. All right. We had 3 answers. And there we go, we're done. Not too bad, so just set it equal to 0 and factor. Main difference is it was 4 terms, so we had to factor with grouping. Alright, let's look at the next problem. Solve the equation 2m to the 5th power equals 16m squared. Alright, this is kind of weird, but once you see something that's slightly weird, just think of what you would do with a quadratic. I'm going to try set this equal to 0. Now, some of you might be tempted to try and divide both sides by m, but we cannot do that. Why? We don't know if m equals 0, and you can't divide by 0, so we cannot do that. Okay? So what we're going to do, oops, that's not supposed to be 5. We'll set this equal to 0 and see if we can factor. That's basically always going to be the plan with quadratics, unless you can do the square root property. So minus 16 from both sides. We can't actually combine those, so we're just left with 2m to the 5th power minus 16m squared equals 0. Once again, my goal is always to try make my equal lines line up as much as possible to make my work readable. All right, let's see. Can I factor? Well, they both share a 2 and an m squared, so let's take that out. I've noticed something. See that minus sign? I'm thinking this could possibly be either the difference of squares or the difference of cubes. Well, that's a cube. So I know it can't be difference of squares. Is 8 a perfect cube? It is. That's going to factor to difference of cubes. All right, so I'm going to go ahead and do some scratch work. And remember, for your exam, put your scratch work on the side. So I want to factor m cubed minus 8. I'll rewrite this into the m cubed minus 2 cubed so we can see what the a and b values are. Here's my a, here's my b. And using the formula, this is going to factor out to m minus 2, m squared minus 2m plus 2 squared. So that'll be m minus 2 times m squared minus 2m plus 4. Okay, that's my scratch work on the side. All right, I'm going to just rewrite this slightly so I can fit everything in and keep the equal sign lined up. 2m squared, m minus 2, m squared minus 2m minus plus 4. All right, we factored it all. Now you might say, can we factor this? Well, if it came from your difference of cubes, and in the beginning they didn't have a common factor, the trinomial is not going to be factorable. So to solve this, we're going to set each one to 0. So 2m squared equal to 0. m minus 2 equal to 0. And m squared minus 2m plus 4 equal to 0. This one I can solve. Let's see. Divide both sides by 2. Now this is a really nice problem. And when I say that, it's possible it could show up on your exam, or something like it. Use the square root property on both sides. And remember, you really, really, really need to show that plus or minus. Okay, cancels, then m equals, well, plus or minus the square root of 0 is just 0. So we have 0. Awesome. Solving this one, that's not too bad. That's just m equals 2. And this one, okay, this is not factorable. How do we solve a quadratic that's not factorable? Quadratic formula. All right. A, B, and C, what are they? Well, my A value is going to be 1. B, negative 2. C, 4. Let's write that down. C, B, A. And remember, the signs are important. Now, we're not going to write x equals. That's the generic form. We're going to use m equals. Negative B, plus or minus the square root of b squared minus 4ac all over 2 times a. Okay. Now, be careful. When you're writing out your formula for the quadratic formula, your bar for the division should be longer than your radical. And you should not be drawing the line under the m. It's m equals and then this whole idea. Okay, so I will be taking a look at that. Make sure the way I show work, a good idea is just to see how it is and copy it down. Okay. That's why I have you follow along with me in lecture videos. Okay. 4 plus or minus square root of 4 minus 16 all over 2. Okay, and then m equals 4 plus or minus root, that's going to be negative 12 over 2. Okay, so at this point, depending on what the instructions are, we're either going to stop or continue. How do we know that? We have a negative under the radical. So this is either going to be an imaginary number, because we're going to start working with complex numbers, remember I, or we're going to say it's an imaginary number, so there is no solution for this. In our directions, it did not say to solve over the imaginary numbers. So if it does not say to solve over complex values, you would just say no real solution. But what if it did say? Let's go ahead and take a look at what if it did say. So if it did say to solve over that, you would have m equals 4 plus or minus. We can simplify the 12 and the I, so that would be 2i root 3, or 2 root 3i. The I needs to be at the end. divided by 2. And then m equals 4. Oops, let's factor out the 4. 2 times 2 plus or minus root 3i divided by 2. The 2's would cancel. And you'd be left with m equals 2 plus or minus root 3i. So this is if you solved over complex. And the other one is if you solved over real numbers. So if you were solving over real numbers, you would say no real solution. Sorry, running out of space on this problem. Alright, so let's take a look at the next example. So solving rational equations. Alright, let me go ahead and erase that there. That was not supposed to stay. Okay, so solving rational equations. So one thing to note, when there is a variable in the denominator, you must check for, and we call it again, extraneous roots. Alright, or what you're going to do is you're going to check to see if your answer makes the denominator equal to 0. And if it does, we cannot use that number. Okay, because remember, we cannot have 0 in the denominator. So just looking right here, I know we can't let x equal 4. Why not? Well, if I plug 4 into that equation, x minus 4, so not the equation, into that binomial, then I'll get 4 minus 4, which equals 0. I can't have 0 in the denominator, so I know x cannot equal 4. But, for example, if I was looking at that trinomial over there, I'm not certain for which values of x I can't have. But for this base, I know x can't equal negative 2. Alright. Now, let's go ahead and solve. So when I'm working with an equation, and once again, how do I know it's an equation? Because of that equal sign. What I can do is when I find my LCD, I can use it to cancel the denominators. Now be very, very careful. For expressions, you cannot just cancel denominators. But you can for equations. Alright? Please keep that in mind. So what is our common denominator? Well, in order to find out what it is, I need to factor this. Alright, so now I've factored it. Let's see my lowest. Oh, it's just going to be x minus 4, x plus 2. All of the denominators are happy. So, let's go ahead and rewrite this. I do say so quite a lot. Alright, x squared plus 14. Ooh, that was ugly. All over x minus 4, x plus 2. Alright, so now once again, what do I use the LCD for? Because it's an equation, I can use it to cancel the denominators. If this was not an equation, I could not do that. Please, please, please remember that. Alright, so multiplying both sides by this. Now why can I do this? Because I have the multiplicative property of equality, which states that what I would multiply to one side, I can multiply it to the other. This is why I don't need to do the building up property that we're used to. You know, normally we use the building up property. We don't need to use that here because we're in equation land. Alright, so when I distribute this in, those cancel. And then, let's say I got to show the distribution on this side. So I have the x minus 4 times the x plus 2. Distributing that in, so it's times the 2x over x minus 4 minus, ooh, this is looking ugly, x minus 4, x plus 2 times the 3 over x plus 3 equals x squared plus 4. Alright, so now once I do that, that cancels with that one, and that, ooh, I don't know where the 3 came from. That shouldn't be a 3. There we go. And the 2 cancels to the other 2. Alright, what are we left with? We're left with 2x times x plus 2 minus 3 times x minus 4 equals x squared plus 4. Alright, so we have a quadratic equation. How do I know that? Because we have that x squared right there. Or you could see the x times the x, so we know we're going to get quadratic. So the plan normally for quadratics is to set equal to 0 and see if you can factor. That's the main plan. Okay, let's go ahead and do the distribution. All right, and then what do we get? We get 2x squared plus 4x minus 3x plus 12 equals x squared plus 4. And we see it's, once again, we see it's quadratic. So let's go ahead and get everything to one side and move everything to the left side. And then subtract the 14 from both sides. And we'll simplify these guys while we're at it, combining those like terms. We get x squared, oops, plus x. And then, oops, that should be a minus 14 there. That'll give me, let's see, negative 2 equals 0. Right. All right, can I factor this? We want to subtract to end up with a positive x, so we know we're going to have a minus and a plus. Factors of 2 that give me 1. Let's see, well, if we have the positive 2 and the negative 1, we can add them to get a positive 1. All right, there we go. And let's see, solving for x, you have to set each one to 0. Okay, x equals 1, x equals negative, negative 2. So careful, we can't just box our answers right now. Why not? Remember, our variable was in the denominator, and I think I recall saying earlier, we cannot let x equal negative 2. Why not? Because if I plug a negative 2 in here, I get negative 2 plus 2, which equals 0. Cannot have that happening in the denominator. So, the x equals negative 2 does not work in our denominator. Extraneous makes denominator equals 0. Oops. So once again, you need to provide the reason why you crossed out one of the answers. And then let's see, does 1 cause a problem? If I plug 1 in here, I get negative 3. If I plug 1 in there, I get positive 3. If I plug 1 in here, I get a negative 3 times a positive 3, which is negative 9. So that's not a problem either. So we do actually have one solution, which is x equals 1. All right, not too bad. Now we have another example. So this is a word problem example. Trent takes his boat 6 miles downstream with a 1.5 miles per hour current. The return trip against the current takes 1 hour longer. Find the speed of the boat in still water. All right, so this is a motion problem, so I'm going to go ahead and use my motion chart. Distance equals rate times time. Distance equals rate times time. And so we have two options. We have going upstream and we have downstream. Now what do we know? Well, we know that, let's see if this is the river, right? I'll choose blue, why not? Got the blue current going. And he has his little boat, and at one point he heads upstream in his little boat, and then he gets to a point, so he heads up 6 miles. This is where he started. And then he comes back in his boat. So in total, the distance traveled both times is 6 miles. Okay, now let's see. What else do we know? We know that there was a 1.5 mile per hour current. And we want to find the speed of the boat in still water. So that's going to be my variable. My variable is the speed. So B. Now, when you're heading upstream, the speed you're working at, you're also fighting a current, right? So whatever speed you had, for example, when you're going upstream, even though we don't know what it was, we're going to call it, no, B looks too hard. Let's go ahead and call it X. Let X be the speed of the boat. So you're heading upstream, X miles per hour, but you're fighting a current. You're fighting a 1.5 mile per hour current, which means however fast you're going, it's still, you're losing power by 1.5 miles per hour. So going up, you lose some power. Now when you're heading back down, you're going with the current. So the rate you would normally go, which we're going to assume is the same rate for this type of word problem. In 103, you can assume it's the same rate unless you're told otherwise. Things get more tricky in the higher math classes. Okay, so going downstream, speed of the boat, but you're going with the current, which means the speed of the current is helping you, right? It's pushing you downstream. So you add the speed of the current. So it's x plus 1.5. Now we just need to fill in the last box, the time box. Well, let's see. We know that the current takes 1 hour. Going the return trip takes 1 hour longer. But what I want to do is I'm going to use the other boxes to fill in the last box. That's pretty much what you always do. So distance equals rate times time. Solving for time, let's divide both sides by rate. And we get the distance divided by rate is time. Let's do that. Distance divided by the rate. So 6 divided by x minus 1.5 is the time. And then for the other one, distance divided by rate. 6 divided by x plus 1.5. Now, we can use the last box filled in to write our equation. And what do we know? Well, we know that the return trip takes 1 hour longer. So, let's see. The return trip was this one. So 6 divided by x plus 1.5. This trip is 1 hour longer than the other one. So how could I make them equal to each other? Because if I said the two trips were equal, that's not true, right? Because technically, upstream took more time because you're fighting a current. So this one took longer, going upstream. The downstream one took less time. So to make these two equal, what I have to do is I'm going to have to add something to the one that's a shorter trip. So which one's the shorter trip? Well, going downstream or with the current, that was shorter. So to make them equal, I'm going to go ahead and add. Remember, it takes 1 hour longer. I'll add the one to this side. And now they're equal, because going against the current took longer. So to make this side equal, I had to add that 1. Okay, now we can go ahead and solve. So another way you could think of the problem, if you wanted to, for setting this up, and it would work the same, is you could just say that the difference in time between these two trips was 1 hour. So setting that up, it would look like 6 over x minus 1.5 minus, 6 over x plus 1.5 equals 1. So you could say the difference between the two times was 1 hour. That's another way to set up the equation. It would still come out to look like this one. Once again, there are different ways at looking at how to set up equations. So, we have our rational equation with a variable in the denominator. Let's go ahead and solve this. Now, we can use the LCD to cancel out the denominators if it's an equation. We're lucky it is. So our LCD is x minus 1.5, x plus 1.5. Let's go ahead and multiply both sides by that. Oops, that parenthesis does not look that nice. I'm going to take that out. X minus 1.5. Now, once again, why aren't we doing the building up property? Because it's an equation, we don't have to do that anymore. All right, x minus 1.5, x plus 1.5. 1.5. Okay, this gets distributed in. When it goes to the first term, nothing cancels it, because it's just times to that 1. Then, when we distribute it to the second term, the plus cancels out, so we're left with the minus version. Equals, and then this cancels with that. We're left with 6 times x plus 1.5. Okay, let's see. We're going to go ahead and solve this, so I got to get rid of all the parentheses. Now this is a conjugate pair. So let's see. We have the 1.5 times 1.5. That'll be 2.25. So this is x squared plus minus 2.25 plus 6x. 6 times 1.5 is 9 equals 6x, and then 6 times 1.5, I already did that, is 9. Okay, now, combining like terms. Actually, we can go ahead and, let's see, subtract 6 from both sides. Those cancel out each other, actually interesting. Then, subtracting 9 from both sides, those don't cancel out. So what are we left with? We have x squared minus 2.25 minus 18 equals 0. Now we're going to combine these two like terms. The 2.25 and the 18. It's going to be x squared minus 20.25 equals 0. You know what? We could try the square root property because we don't have just an x term. We only have the x squared. Let's do that. Change of plans. Let's add the 20.25 to both sides. I'm going to try use the square root property. X squared equals 20.25. Oops. Alright, let's take the square root of both sides. When we do that, please remember plus or minus, very important. Those cancel. We're left with x equals plus or minus square root of 20.25, which simplifies into approximately, or actually it simplifies to 4.5. So what do we know? Well, x was the speed of the boat. So the speed of the boat in still water is 4.5 miles per hour. So the main sort of tricky part of this problem, one, was figuring out how to use that 1 hour to create our equation. And also just bearing in mind when you're going upstream, you're fighting a current, and when you're going downstream, so fighting a current, and then you're joining the current. Okay, let's look at this. Solving absolute value equations. So, when solving absolute value equations, you must check for extraneous roots. And you must also remember that absolute values cannot equal a negative value. Okay, one thing here that I need to fix is this should equal 2. That 2 should not be there. Hopefully I fixed that in your notes by the time you've got your notes. Okay. So, when we're solving absolute values, what we first want to do is get the absolute value by itself. So get absolute value by itself. First thing. So on our first equation, the absolute value is not by itself, so I'm going to go ahead and divide by that 5 to get it by itself. And once again, or not once again, now I have it by itself. So I'm going to go ahead and split this. We know that what's in the absolute value is either a positive or a negative number. We don't know which one it is, so we're going to have two options. One, what's inside is positive. Or we know that what's inside is actually a negative value, and we take the absolute value. Okay, so those are two options. We have the negative or the positive version, which creates two equations. But we're going to solve both. So, subtracting, let's see, subtract the 10 from both sides. And then I will add the 4t to both sides. And we have negative 8 equals 4t. Now we can divide both sides by 4. And we get negative 2 equals t. Now let's take a look at the other one. First, let's distribute in that negative 2. Negative 2 plus 4t equals 10. So because our variable is already positive, I'm going to leave it on that side, and I'll go ahead and add the 2 to both sides. So we get 4t equals 12. Solving for t, let's go ahead and divide both sides by 4. And we get t equals 3. Now we need to check. Does this make sense? Well, with our original equation, we have 5 times, 5 absolute value of 2 minus 4 times negative 2. Does that equal 50? Well, 5, and then let's see, 4 plus 8. Oh, that's 2 plus 8. 2 plus 8. That's going to be 5, so 8, 9, 10. So that's the absolute value of 5 times 10. 5 times 10. Yep, that equals 50. We're good. That worked out. Okay, so we can go ahead and box that answer. That one works. Now let's check the other one. Does that also equal 50? So we get 5 times 2 minus 12. So that's going to be 5 times 10. So 5 times the absolute value of 10 is just 5 times 10, which equals 50. Awesome, they both work. So sometimes what might happen is either you'll end up with a different number, or you might, I think actually most of the times if you end up with a different number, then that's what's wrong. And then you would say that that's an extraneous solution. Okay, take a moment, try solve this one by yourself, and check back in with me in a second. Alright, so as usual, we want to get the absolute value by itself. We got to isolate that. A lot of the times you isolate the weird looking item. So let's subtract 8 from both sides. Then we get as the value of 7w minus 3 equals negative 6. So hopefully you noticed there was something wrong. Can an absolute value ever equal a negative number? The answer is no. That cannot happen. Okay, so since what we would write is an absolute value, capital, an absolute value cannot equal a negative number. So there is no solution. Once again, the problem was absolute value should always be positive, and that's a negative 6. That's not possible. Alright, let's take a look at the next problem. Alright, so you might be wondering if that is another typo, and no, that is not another typo. We have 2 absolute values equal to each other. But don't worry, this is pretty simple. All you're going to do is rewrite it kind of similarly to like what we did before. You'll have one equal to the negative version and one equal to the positive version. It does not matter which side gets the positive or the negative, as long as one of the equations gets a negative and the other one gets a positive. Because we know for absolute values, one of them, the answers could be positive, or the other version, one of the answers could be the negative version. For example, if you know that x, the absolute value of x is 5, there are 2 options. One, x is actually negative 5, or x is still just a positive 5. Because remember, the absolute value of negative 5 is still 5. So that's why we take the positive and the negative options. Okay, let's go ahead and solve. You can pause the video, try solve by yourself. Adding the 5 to both sides, and we get x equals 6 for one of our answers. Oops, shouldn't box that just yet. Got to make sure that makes sense. And then, let's see, 2x minus 5. Let's distribute that negative first. Negative x minus 1. Adding x to both sides. Minusing 6 from both, minusing 5 from both sides. Adding the 5, adding the 5. And lastly, dividing both sides by 3, we have x equals 4 over 3. Now we need to go ahead and make sure that both of these work. Okay? So, checking both of them. I'm going to go ahead and just do the checking on the side. So for the first one, x equals 6. Let's plug that in. Do they end up equaling each other? So plugging in 6 for both sides, for x, we get that this side, that's going to be 12 minus 5, Absolute value of 12 minus 5 is going to be 7. Absolute value of 7 is 7. Now let's check the other side. That's the absolute value of 7, which is 7. Are they the same? Yes. So the first one checks out. We can go ahead and box it. Now let's check the next one. All right. Absolute value of 2 times 4 over 3 minus 5. Is that the same as 4 over 3 plus 1? I'm going to go ahead and convert that into a decimal for solving. So that's 4 over 3 is going to be 1.5. Sorry, that's not going to be 1.5. You know what? I'm not going to convert that into a decimal. You know why not? Because that's a repeating decimal, because it's divided by 3. I take that back. Got to work with the fractions here, folks. So 8 over 3. Now we're going to build up the 5, so that's going to be 15 over 3. 8 minus 15 over 3. What do we get with that? So let's see. 8 minus 15, negative 7. Absolute value of negative 7 over 3 is 7 over 3. Now let's check the other side. That's going to be absolute value of 4 over 3, plus, we're building up the 1, we'll get 3 over 3, and we get 7 over 3. Absolute value of 7 over 3 is just 7 over 3. They're the same. Works out. So I can go ahead and box that answer as well. So once again, the problems that require you to check for your answers, I would like to see, and actually I need to see on the exam that you checked for the final answers. Okay? That'll be something I put aside points for. So for absolute values, you need to check. For rational equations, you need to check. All the ones that I've mentioned, you should check. You need to show the work for checking. Okay, next one. Solving radical equations and equations with irrational exponents. So the goal in solving radical equations is to get the radical by itself. Then raise both sides to a power to cancel out the radical. Second, when solving a radical equation, you must check for extraneous roots. As usual, anything that gets strange, you're going to probably be checking for roots. So, solving this, what did I say? You need to get the radical by itself. So the way I like to think of it, it's just a funny way. The other numbers are afraid of the radicals, so they like to run to the other side of the wall to feel safe. So the 4 is going to run to the other side to feel safe away from the radicals. Because people are afraid of radicals, right? Well, sometimes. Maybe you're a radical yourself. Okay, so let's add 4 to both sides. Square root of x plus 10 equals x plus 4. All right, radicals are by itself. Other numbers are scared and on that side. Now, what's the plan? We're going to raise both sides to a power that will cancel the radical. So, if that was a cube root, we'd raise both sides to the third power. But what's the thing right there? That's a 2. If we don't see it, remember it's a 2. Raising both sides to 2. That will cancel that out right there. And we're left with x plus 10 equals x plus 4 squared. Now, hopefully you did not think about just distributing the 2 in. That is very, very, very wrong. Don't make me cry. You need to go ahead and multiply that out. That is the binomials multiplying together. Makes you do the FOIL. So x plus 10, that x started to look like a fish. Okay, x plus 10 equals x squared plus 8x plus 16. Now, combining like terms, it's a quadratic, so we're going to get everything to one side. Subtract x from both sides. Subtracting the 10 as well. We get 0 equals x squared minus 7, plus 7x, plus 6. Let's see, can I factor this? Factors of 6, and when I add them, I get a positive 7. That'll be x plus 6, x plus 1. Now let's set both sides equal to 0. And x equals negative 6, x equals negative 1. But before I can box these off, I need to check. So let's check. Let's check for negative 6, and then we're going to check for negative 1. So on the actual exam, I will leave room for you to do more checking. I didn't make enough room in my notes. Okay, so negative 6 plus 10 minus 4. Does that equal negative 6? Once again, I just plugged x into where I saw x in the equation. So that's going to be the square root of 10 and 6. So that's going to be 4 minus 4. Does that equal to negative 6? Square root of 4 is going to be 2 minus 4. Oh, that's not looking like it's going to equal negative 6. Alright, that's negative 2 equal to negative 6. It is not equal to negative 6. So this is extraneous. Now, you would not need to write out the reasoning for why it's extraneous if you left your work up here. If you erased your work like I did, you would need to write out your reasoning. But if you leave your work like there, that's good. And when you label it check, that also tells me what all that work is. So you wouldn't have to necessarily box it off to say scratch work if you tell me what you're doing. Okay, now let's see, checking negative 1. Once again, we're just plugging it in where we see x. Does that equal negative 1? That's going to be square root of 9 minus 4. Is that negative 1? Square root of 9 is 3. 3 minus 4. Is that equal to negative 1? Ah, yes it is. It checks out. So my solution is negative 1. One of them worked, one of them didn't. Now we have a new type of equation. So notice this one has 2 radicals. What do you think our plan should be? Well, pretty much for every number of radicals you have in your equation, that's how many times you're going to have to end up isolating and squaring. So this thing right here was just sort of one cycle. We squared both sides. But because we have 2 radicals, we're going to have to end up doing that squaring twice. So normally, I like to get the radical that looks the biggest and isolate that one first. Now the 3m plus 1, that looks the biggest, so I'm going to isolate that one. So I'll add it to both sides. And then I'll go ahead and add the 2 to both sides as well to get that radical by itself. Once again, we can only get one radical by itself at a time. Now, our plan, square both sides. Now, it won't end up canceling this radical, but it'll cancel this one. So we'll have the square of m minus 1 plus 2 equals 3m plus 1. Huzzah, we got that side cleared. But we have to multiply this out. Remember, we cannot distribute in that 2. If you did that, for shame. Okay. Root m minus 1 plus 2. Root m minus 1 plus 2. Foiling that out, that's going to be m minus 1 squared plus 4 root m minus 1 plus 4 equals 3m plus 1. Now, when we first multiply those two together, that cancels that radical there, actually. So we're left with m minus 1 plus 4 root m minus 1 plus 4 equals 3m plus 1. Whew! Darn, we still have a radical. So we're going to have to do that same cycle over again. So isolate the radical. Let's see. I'm combining like terms right here, though. I'm going to do that first before I add anything else. So I'll have m plus 3 plus 4 root m minus 1 equals 3m plus 1. Now let's get the radical by itself. So minusing m from both sides. And then I'll go ahead and subtract 3 from both sides. So I'm left with 4 root m minus 1 equals 2m minus 2. The radical's almost by itself. Let's get rid of that 4. Dividing both sides by 4. Now I can go ahead and square both sides. Actually, let me do it on the next step. I'm going to simplify first with that, actually. Let's factor out that 2. We can cancel out a little bit here, so that it's gone there, and that's a 2. So then I have square root m minus 1 equals m minus 1 divided by 2. Let's bring our work up here. Okay, one thing to note. I am very pleased about this problem. Why? I have managed to keep my equal signs pretty lined up, which makes it really easy for other people to follow, especially when grading. Okay, so now, radicals by itself. What is the plan? Square both sides to get rid of that radical. So it does indeed get rid of the radical, huzzah. So m minus 1 equals, okay, but that has to be squared. So that's going to be m minus 1 over 2 times m minus 1 over 2. So minus 1 equals, well, in the top, we have m minus 1 times m minus 1, and in the bottom, we had 2 times 2, which is 4. Okay, we have to FOIL out that top. So foiling it out, we get m squared minus 2m plus 1 divided by 4. Let's get rid of that 4 by multiplying both sides by 4. And then we can distribute it in. Alright, so we have 4m minus 4 equals m squared minus 2m plus 1. It's quadratic, which means we want to get everything to one side. Set it equal to 0. And what do we have? M squared minus 6m plus 5. Can we factor that? Yes, we can. M minus 5, m minus 1. Which means we have m equals 1. Oops, I jumped a step. I have to set both of these equal to 0. So m equals 1 and m equals 5. Okay, so you would need to check both of these. I don't have that much room, so I'm just going to go ahead and check them out here. So 5, let's see. If I plugged 5 in here, I would get the square root of 4, which is 2, minus 3 times 5 would be 15 plus 1. Square root of 16 is 4. So 2 minus 4, does that equal negative 2? It does. Okay, so the 5 checks out. Now let's try it with a 1. One minus 1 would be 0. Square root of 0 is 0. Then 3 times 1 would be 3. Plus 1 would be 4. So that's the square root of 4, which is 4. So 0 minus 2, is that negative 2? Yep, it checks out. Once again, that is something you should show for the side work. I just did not include enough space here to allow for that. Now let's take a look at example 9. Solve the following equation containing rational exponents. So notice we have the rational exponents. Well, the idea is pretty similar. You're going to be raising to the same power, or not to the same power, you're going to be raising to a power to cancel out the exponents. So first, I'm going to write this in a form that I recognize. That 3 is a cube root. So this would be 2 times the cube root of x plus 1 squared equals 8. Actually, I'm going to rewrite that because I think it'd be nice to get rid of the cube root first. And remember, we can rewrite it this way. Okay, so I want to isolate the radical, get it by itself, so let's divide both sides by 2. Then we have the cube root of x plus 1 squared equals 4. Now, to get rid of a cube root, we're going to raise both sides to the third power. That cancels that cube root, and I'm left with x plus 1 squared equals 4 cubed, which is 64, I believe. Yep. All right, hey, look at this. That is set up perfectly for the square root property. So we can square root both sides. Remember that plus or minus, very important. Cancels with a 2. X plus 1 equals plus or minus the square root of 64, and the square root of 64 is actually 8. Now, minusing 1 from both sides. Actually, I want to do that in yellow. Minusing 1 from both sides. X equals negative 1 plus or minus 8. Let's continue on the side here. I can split that into x equals -1 plus 8 and x equals -1 minus 8. So x equals -9 and x equals 7. But because our problem actually has a radical in it, a square root or a cube root actually, we need to check our answers. So let's check 7 and check -9. So checking 7. Well, that would be 2 cube root of 7 plus 1 squared. Does that equal 8? For checking 9, it would be 2 times the cube root of -9 plus 1 squared. And we want to know if that equals 8. Pause the video and try to check these by yourself and see what you think the answers are. Okay, so hopefully pause the video. And it's going to be 2 cube root of 8 squared. 2 cube root of, 8 squared. I'm going to switch that around. I want to do the cube root of 8 first, and then I'll square it. So that's going to be 2 times 2 squared. So that's going to be 2 times 4, which is 8. Checks out. Awesome. We can box 7. So then we have 2 cube root of -8 squared. Is that equal to 8? Actually, I can leave that off for now. Once again, I'm going to switch this around. I like making the problem smaller before I make it bigger. And remember, we can switch the cubes and the squares. That's an 8. That's 2 times -2 squared. That's 2 times 4, which is 8. So they both check out. Awesome. Okay. So a lot of the problems in this section, you do need to check your answers. So, I believe this is the last objective for 1.6. We're going to look at equations in quadratic form. Now, what does it mean for an equation to be in quadratic form? Well, it looks quadratic because you have one item, let's say, I'll just call it one item, in the equation, and then you have the square of that item. Okay. For example, you might have, look at this problem right here. We have 2x squared minus 3 and 2x squared minus 3 appear twice, and one of them is the square of the other. Just like how in a quadratic equation, you'll see an x and then an x squared. In this problem, we see a 2x squared minus 3 and then a 2x squared minus 3 squared. So this equation is in the quadratic form. It's not actually quadratic, but it's in the form because we have one squared of the other. Well, what do we do when we see those? We use this thing called U-Substitution. So we trick ourselves into thinking it looks quadratic, which makes it easier to solve. How do we do that? What you're going to do is find the item that is not the squared version, okay? So the item that's not the squared is 2x squared minus 3. So what we're going to do is say let u equal 2x squared minus 3. Now I'm going to copy down my original equation. Right now, this problem looks horrible. I would not want to try to solve that, which is why we bring in the U-substitution. Wherever I see 2x cubed minus 3, I am going to replace it with u. Why can I do that? Well, they're equal. If they're equal, it doesn't matter if you swap them in and out, right? So I'm going to replace this and this with u. Which means I have u squared plus 36 times u plus 35 equals 0. Now let's rewrite that again. U squared plus 36u plus 35 equal to 0. Does this equation look way nicer than the original one? I mean, I think it does. I totally know how to solve this quadratic equation. I can just factor it. That's u plus 35, and u plus 1. That factored super easily. And then I just set each factor to 0 to solve. So, u equals negative 35, and u equals negative 1. I would be really tempted to just box the answers. The problem is, I'm not being asked to solve for u. I'm being asked to solve for x. Oops. What do we do? Well, no fear. Remember, u is the same thing as that. So let's just go ahead and swap it back in. We used u when we needed it. Now we don't need it anymore. We'll go ahead and swap out u and replace it with what it's equal to, the 2x squared minus 3. So the u was useful for a while. It now is no longer useful. So we'll swap it back out. Okay. Once again, these are both quadratics, so solving. Actually, you know what? We could use the square root property on these because there's no x term. I'll go ahead and add 3 to both sides. And then I can divide both sides by 2. So we have x squared equals 1. And taking the square root of both sides, remembering that plus or minus, cancels out. I'm left with x is plus or minus square root of 1, which is just plus or minus 1. And for the other side, add 3 to both sides. 2x squared equals negative 32. Let's see, dividing both sides by 2. I get x squared equals negative 16. Alright, so when I take the square root of both sides, a problem will appear. I have a negative 16 under the radical. So once again, depending on what these directions might be, you would either say no real solution because of that negative under the radical, or you would continue solving and x would equal plus or minus 4i. How do we know which one it is? If it says to solve over complex, normally that's when you continue. And since I did not say, it says to solve over complex numbers. Aha, I didn't read the directions. Naughty me. Okay, so because it says solving over complex, we would go ahead and include the complex solution. So we would continue on to solve and write 0 plus or minus 4i. Okay, notice I added that 0. Please answer in complex notation. Don't just answer as x equals 4 plus or minus 4i. Okay, that would not be considered correct. Please answer in complex notation. It's the a plus bi form. I don't know why the 1, did I not write a 1 earlier? Interesting. Okay. Do I need to check for extraneous roots? The answer is no. There's nothing wrong with squaring a value. So we're good. No need to check for extraneous roots. Now let's take a look at I believe this is the last example. Now, we're told to solve the quadratic form equation. How do I know it's the quadratic form? Well, remember, what I'm going to look for is 2 items that are the same, except one is the square of the other. Now, this should actually be a w here. Hopefully, I switched that. Well, if I look closely, I'll notice I have a w, technically squared, and then a w that's not squared. So this is quadratic form. So what I'm going to say is let u equal w to the 1/3 power. So wherever I see that, I can swap it out with u. Okay, u is going to equal that, which is right there and right there. So swapping that out, replacing it with u. Once again, the goal for U-substitution is to make your problem look simpler. Alright, so now I have 2u squared equals 3u plus 20. Does this look simpler than what it used to? Well, I kind of do. Well, it's a quadratic. Let's set it to 0 and solve. So 2u squared minus 3u minus 20 equals 0. Can I factor this? Let's see, factors of 2 and 3. Well, I want to subtract to get a negative 3. So that means I can have a positive and a negative. So let's see. Factors of 2 are just 1 and 2. And factors of 20 are 1 and 20, 2 and 10, not 3, 4 and 5, then 5 and 4. Okay, so these are the factors of 20. And I want to end up with a negative 3. So when I take that neg 1.2, and then what should I try? Let's try the 4 and the 5, why not? I have two options. Multiply across, so I get 8 and 5. Can I subtract to get a negative 3? I can. A negative 8 and a positive 5. So the negative comes from the 2 and the 4, so that'll be 2u minus 4, and then the positive came from the 1 and the 5. So 5 and 1u. Alright, let's set both of these equal to 0 and solve. If you want to go ahead and try solve this by yourself, try to do that and check back in with me. Okay, so one thing to do with my scratch work here, I'm not going to erase it, but I'm just going to go ahead and mark the fact that it was scratch work. Okay, so solving this, 2u equals negative 5, u equals negative 5, divided by 2, and then on this side, u equals 4. But we're not asked to solve for u, careful, we need to solve for w, which is to the 1/3 power. So replacing that with the 1/3 power, we can solve and we get w to the 1/3 equals negative 5 over 2, and w to the 1/3 equals 4. Go ahead and pause the video and see if you can figure out how to solve this. Okay, so to solve for w, we're going to raise both sides to the 3rd power. That'll cancel out with the 3, and I'm left with w equals negative 125 over 8. And on the other side, once again, raising both to the 3rd power, I get w equals 4 to the 3rd power is 64. All right. And you go ahead and check these to make sure they work with the equation. And they do. So those are our answers, boxing them. And that is it for this section. Remember to feel free to email me if you need any help with them, or join me with my office hours, which are listed on the top of your La Lima page.